Yeah. So, good afternoon, everyone. It's April 2024. I'm speaking from Goa. We have an interesting guest today. More about Vikram Vyas in a minute. It's been rainy in Goa today. We've had April showers, a lot of thunder and all that. So I was just wondering if the sound would be okay, but it's fine. And now on to the subject. So Vikram Vyas is my old friend of about 20 years. I feel like a Rip Van Winkle here. And Vikram and me are talking technology today. So I'll leave Vikram to do all the talking and I'll keep quiet. Vikram is behind this project called SimTanka. SimTanka. Sim standing for simulated, I guess, and Tanka for a tank. Vikram, over to you. Over to you.
Thanks, Frederick. It's very nice to um, see you. And since last time we communicated, the technology has improved so much that we can, actually have this kind of live meeting. So, as you said, I'm basically a theoretical physicist, and initially I took a break from academics and I spent some time with a voluntary organization called Ajit Foundation in Bikaner. Also spent a considerable time with Bev Food College, Tilonia. And one of the things I was doing there was to see to what extent my understanding of physics could be used for sustainable use of water. And in particular, I got sort of really hooked to rainwater harvesting, partly because my we work, the organization, Ajit Foundation, works in Bikaner, and my grandparents come from Bikaner. So I'd seen their tankas in their house. Uh, so it was always on my mind. And
These
as you know,
tankas, these tankas are those amazing kind of traditional water storage devices which have been built over centuries, right?
right. So these ones were for houses. The many of them were used for for farming. But the one which, like in my grandfather's house, was basically for as a kind of buffer. The house had a terrace and a angan, and the water tank was in the base, was kind of underground. But there was a big catchment area, what they call agor, behind it. Unfortunately, like everywhere else, all those has disappeared. That house has no longer has that rainwater harvesting system. But yeah, that was the traditional system. And one of the reason I really got into this, was that I was wondering why people are why people are leaving rainwater harvesting. Now, of course, there are many reasons. It's a complex kind of question, because you get pipe water, you would not, and but one of the things which seemed to me was that they were very unreliable. That because they depended on a rain, which were, while the amount of water you need is always kind of fairly constant. Maybe it varies from season to season, but there's a well defined kind of pattern to that. But the source, the rain is, as we all know, is highly unpredictable. Of course, it has some pattern, but it's still, especially with global warming, we are going to see extreme fluctuations in rain, droughts followed by intense flooding. So I wanted to understand that how can we make these systems reliable, and in a manner so that hopefully they can be integrated with other sources, maybe with pipe water, that together they can meet the needs. So that was the original impetus, and the original software through which we got in touch with each other was written in Visual Basic, and it was kind of quite cumbersome to use, because the user had to enter monthly rainfall for like 5 years manually. And so
But Professor, before we get into the deep end of the pool,
right,
literally and metaphorically, what
yeah,
struck me about your work was that you were actually, using technology in a very applied sense for very real purposes, and in a way that really surprised me, because you were taking free and open source and using it to create solutions which can help people's lives. But to get an overview of it first,
yeah.
how exactly is your product has your product been making a difference?
See, the original product, the one through which we got to know each other, the Simtaka, which ran on Windows 98, it had a surprising impact, which was kind of unanticipated. When I did it, it was my motivation was to, I was focusing on Rajasthan, but one of the great things about free and open source is that I just somehow I just spread the word that basically I can send you the source file, you can compile. It was Visual Basic, everyone could do it. I mean, anyone who had Windows could do it. So what happened was that one of the great thing is that about as you know about open sources, it allows people to adopt technology more easily without hindrance. And in this case, many people either physically asked me to send them a floppy with the Simtaka software, or I would send them a link from a place where they could download the source and then make their own app using Visual Basic. In this manner, people started using in the parts of the world which I had not anticipated. Sri Lanka, Crete. I think I got a email from some German NGOs working in Africa. I've forgotten. And then over the years, it started appearing in a lot of textbooks on rainwater harvesting, that if you want to find an appropriate tank size, then one of the ways is the Simtaka developed by this guy in Ajit Foundation. I was working with Ajit Foundation then. So it seemed to me that, and as you know, the Windows became obsolete and I went back to academics, but I would not, I mean, at least every year I would get 2 or 3 emails saying that, can you send me a copy of Simtaka? And I would say that, sorry, it has become obsolete. It doesn't work any longer because, but it was on the back of my mind. And so I felt that it could make an impact. It seemed to have made some impact. I know of some people who are very involved in rainwater harvesting. In Bangalore, they used it for designing rainwater harvesting systems in schools in villages. So I know of people who have said that they have used it. So from all that, I guess that it probably was worth pursuing further. And I thought it had made, I wouldn't say it has made a huge impact, but I would say it has made some, it will facilitate if someone wants to use it.
But it's a fascinating idea. It's a fascinating idea that technology can actually help real life solutions. And it's something that, a country like India needs much more of, in that sense.
Yeah. And what I was interested in, the idea of simulation, which, as you know, is very common in physics and engineering and applied sciences, is like, for example, if I'm building an aircraft, I don't want to build a real aircraft and then find out whether it's going to work or not. You just make a computer model and check it. So this is kind of thing I wanted to bring it to everyone, so that if, let's say I'm living in, I don't know, Goa, let's hope you don't have, but let's say in Bikaner, we have Ajit Foundation, and there's a roof of 1,000 square feet. And then I'm saying that, is it worthwhile for me to do rainwater harvesting? Then before actually I build it, I can figure out, I can see that if I make up this thing, then I'll need this kind of tank size and this much water I'll be able to get reliably with say 90% reliability. So that allows me to make an informed choice. And I think that I feel is very important in facing the water situation that we are going to face, that we'll have to conserve water. There's no way out. Even places, you would know in Goa, I don't know about Goa, but I know a little bit about Coorg because I often go and visit Coorg. A place where they get 3 meters of rain is going to face water scarcity. So, so I think a technology in this way can help us both in changing our habits, because you can see that in Simtaka, you can see that if I reduce my budget, the reliability increases. If I ask for I want a huge amount of water every day, you'll say, no, it's unreliable. You'll never be able to meet with rainwater. So I think this is one of the ways it can, as you said, technology, I think has as you know, it's not the complete solution to the problem, but it can give you an important tool in solving the problem.
Technologically speaking, what are the parts of the puzzle? How does it work? Just to give an idea to those who are techies and maybe want some details here.
Yeah, sure. If you go to my website, there's a paper which actually gives the mathematical model and how it is implemented. So you can download the paper and read it. But the idea is very simple, actually. So the problem is the following, that, if I had a way to predict how much it was going to rain tomorrow or day after tomorrow, then we would be able to predict that, okay, if you're going to make this kind of rainwater harvesting system, okay, this is what's going to happen. But since we don't have that kind of knowledge, and it's very unlikely we'll ever have it because weather we know is a chaotic system. So I tried many things, but the thing which I found, the thing which I found the most most reliable, most useful way of thinking was to use the past history to make an estimate about the future. So what this thing does is a very simple thing. Since the technology has improved and there was a possibility of getting a daily rainfall record for any location pretty much in the world now. sometimes by extrapolating, but fairly reliable. So what this model does it's just simple balancing. It's called a water balance. It says that okay, on this day, let's say 5 years back, it's 2024, so 5 years back in 21, 19, on 20th April, how much did it rain in wherever you're making your system? Then it will say that okay, and how much water did I need that day, and how much water was already there in my tank, and then it will check that there was this much water there, it rained this much, I took out this much. Was the tank dry or not dry? If tank goes dry, that means it couldn't meet the demand. So it does it for all the past 5 years. So it is trying to see that if I had actually built a tank 2000 in 5 years back and then used it for 5 years, how would it have performed? And that gives us a kind of odds. So it can only estimate. It gives an odd. It gives you an odd that okay, from what we know from the past 5 years, these are the odds that with this kind of system, you'll be able to meet your demand with this kind of reliability. So
that's amazing. That's amazing. That's amazing. This is your website, Doctor.
Yeah. So if you go up, so if you see there's a Simtaka, the mathematical model.
Yeah.
If you click on that, then it will take you to the paper.
Yeah. Okay. Amazing. Yeah.
Or maybe it goes to the new. It goes to a new page. When the paper will come and you can go through the paper. And if you go to Simtaka iOS app, then it describes the app. And also there's a link to the GitHub where you can look at the source code.
Okay. Can you tell us something about the situation of traditional water harvesting in your part of India where rain is scarce and now global warming and things like that? But in the past there have been solutions which are pretty innovative, and the tankas, and we've heard so much about them in the world of traditional sciences. A little bit about that, please.
Yeah, I'm not an expert in that. I mean, but what little I know from just talking to people who know, and as I said, by seeing things in my own immediate kind of environment in Bikaner. Tankas played a kind of a backup role as far as my understanding goes in a city like Bikaner. The main source of water were the wells and talabs. There were big talabs, and which I would presume were recharging the wells. And one must recognize that it was a quite a tough life. So I don't want to glorify that. That is just by using traditional system. Like my grandmother and my aunts and all, they always talk about how frugal they had to be with water. Now, which is good, but it was also it was an extremely challenging way. So of course, in a sense, a culture and a civilization thrived in that arid area, mainly by using this rainwater, harvesting rainwater in one way or other, because there's no other source. There are no perennial rivers there. So either you harvest using the water which was harvested hundreds of years back and is in aquifer, or you're using the water which was harvested a few months back and is in talab or in your tanka. So somehow you're always depending on rain there. And they had, of course, developed a great intuition about this thing. So in a way, there were many of Gandhians. They were not very happy when I started using this, because they said, "Why do you want to use technology?" I am not. The reason I felt was that things have changed, and can we make those systems more reliable, and can we make them more efficient and make them more attractive again? See, right now in Bikaner, no one is doing rainwater harvesting because you get piped water from Rajasthan Canal. Now, due to global warming, I don't know what's going to happen 50 years down the road, with the glacier melting in Himalayas and all sorts of things. So I think it's only prudent that we go back, we try and integrate those traditions. But more, as you see in Bangalore, for example, and Chennai, where the need for rainwater harvesting has been recognized, and every house has to have a rainwater harvesting system. I think in those places, the new app will be very useful because it will allow them to integrate, because often people build it just because of the requirement. But this can tell you that, okay, you have this much roof, this is what you can do, get reliably. So for this much, you won't have to depend on the pipe water. And you have a better option of integrating these things. To the first part, your real question, about the traditional systems, my feeling is that they were the one reason why the civilization thrived there, but now they are inadequate. So we have to think.
What's your equation? Sorry. Vikram, what's your equation with free and open source? What aspect of it did you like? Why did you use it as an option?
Okay, that's a good question. I don't know. It wasn't really a very well thought out thing. It was an instinctive feeling that I like this idea.
Of sharing knowledge.
I'm sharing knowledge, and the arguments given for free, and Okay, let me tell you the example for why I'm doing it for this particular case. So because it is open, I mean, more than free, I think the open source is more important to me in this particular conference. Because see, I'm building, telling a user or a person who's going to use that these are the probabilities, this is the way things are going to happen. Now that person has a right to ask that how did you calculate all this, right? Now it should not be a black box. A black box, I may have made a mistake. There might be a bug. So there is first thing. It's very very important to expose things which are critical. I think this world over we recognize the critical technology has to be exposed, so that people can see where it can go wrong or where it can be improved. So that was one reason. Other was a collaborative nature of the process that I'm hoping, for example, for historical reason. I mean, not because I like Apple anymore, but for historical reason, I started using Apple when I was a graduate student. Because that time Apple was a small company struggling. I thought I should support a small company, little realizing that it's going to be what it is now. So now with the open source, I'm hoping that I can collaborate and I can port it to other platforms because the code is there. Things to you don't have to reinvent the wheel. Now about the free, I mean that's a bit of a difficult thing because I have no funding at all for this project, and I'm entirely dependent on my wife's. And I left my academic job, So, so what I've tried to do is that in my Simtalk, I put an option that if you find it useful, you can contribute. So this is a model I call the Goenka model because Goenka does this Vipassana thing, and you go and do Vipassana. You don't have to pay anything, but if you like it, then you make a contribution. So I'm trying out I call that a Goenka model. So yeah, free part is difficult because
But of course, some international agency or something like should realize the potential of this and also come to support such efforts, because I think it has a huge, if it has the support and the push, if it gets a push, it can really go places, and someone can take it to another level which you didn't even probably anticipate when you started.
Yeah, no, absolutely. Yeah, I'm hoping. I mean, let's hope someone will. But maybe I'm not very good at writing grants, and also I couldn't get it. But yeah, you do need, for the free part of it, you need some kind of support somewhere. I mean, you can't. See, if I was in academics, I could do it, and I try to do it. But when you're in academics, you have a commitment to teaching and your commitment to research, and then to do this thing was just very very difficult for me. So that's why.
Doctor, in your many years in this field, did you come across any other use of innovative IT for social development in that sense, particularly from North India, because we don't hear so much about it, and I'm sure that there's a lot going on, but we are unaware of these things.
Yeah, I'm sorry, I'm also not aware because I'm really not sort of plugged into the free and open source movement per se. I just, I mean, you're the only person I know that who's really involved, so that's why I always reach out to you.
The spammer who's all over the place.
Because I'm basically a physicist, so I mean, all my friends.
Tell us a bit about your work. While on that point, tell us a bit about your theoretical physicist work.
Well, yeah, I'm a theoretical physicist. I work in what's called particle physics. And I started, my original work was on solving what's called quantum field theories on computer. And slowly I've been more interested in how to, so my work is kind of a mathematical work to understand how do we describe, how to describe the forces in nature. So it's to do with quantum field theory. And there are some, so it's kind of abstract mathematical thing. And the questions I seek are very kind of, at first sight, technical. But they are, okay. So in a way, that if you ask me what you're trying to do, I'm just trying to understand how does a electron behave if the electron had no mass? Where does it get its mass from? There are particles we call neutrinos, which are of a small mass. So there are things related to this, these kind of things, which are very very fascinating when you try to describe them in the language of quantum field theory. And so that's what I'm interested in.
And last question, how do people connect with your work or your site or you personally, some contacts or websites or whatever?
Well, they can write to me, email me. There's a vikram@simtaka.org. That's the best way to
Yeah.
think, and I'll try and reply. And they can download the app if they have iPhone, or if they can download the source code if they wish to. And I must confess that since I'm not really I'm not a good programmer at all. I'm a hacker. I had a problem to solve. I just solved it. I didn't do it in an efficient and elegant manner. So someone who is good at doing all this thing will be very shocked at the way I've written code. There are no comments, very hard to read, etc. But they can get back to me, and I'll try and explain what I did there.
Simtanka.org is your website. Simtanka.org.
Yes.
And in case of someone wanting to contact you, you said your email is vikram@simtanka.org.
ORG, yeah.
In terms of as of now, it's available on the Apple platform, and it should soon be available on Android also.
I just started teaching myself how to code it. Just yesterday was my first foray into that. I don't know when I'll be able to do it, but I hope I'll find people who are expert in this, and hopefully it should not be that difficult. Because now I know it works. I know how to do it. It's now a question of translating to another language. It's not easy, but
sorry, friend. Carry on.
No, I'm just saying that it should not be that difficult now that I know it can be done for one language and one platform. So porting it should not be. The conceptual problems have been solved. Only the technical problems of going from one platform, one APIs to one, all those things have to be done.
Yeah,
it's a doable thing.
Thank you. Thanks a ton, doctor. That's so interesting, and keep up the good work. I've always been a great fan of your work. It was so mind-blowing to realize how this abstract thing called technology and code could make such a difference in the lives of common people. And I appreciate the motivations that you have of sharing your knowledge, creating it, putting it out there, making it accessible to everyone, responding to every email you get. I always know that you will send me back a reply. Keep up the good work. I will definitely spam everyone with this video, because I think it's such a good job and people should be inspired by such work.
Yeah.
Thank you so much.
Yeah. No,
we'll be in touch. We'll be in touch.
Okay. Thanks.
Yeah.
Thanks
Bye.
a lot.
Bye.
Bye.